Hi and welcome to a new tutorial. This time we're not going to do any XR related stuff, but we're going to look at something regarding shaders. And I prepared something like a DissolveShader for you. So whenever you think of something that will only appear and disappear at a certain distance, you can use this shader, for instance, in a dungeon as some kind of lamp or something else, or for simple discovery of an unknown area. And without further ado, let's just see what we're going to do. So I start the scene. I just downloaded the Unity samples for URP. As you can see, when our character walks, objects are still appearing with a little noise on it. You can jump on it. These are solid objects, and as they appear in front, they disappear in the back. There's already a noise on it, which makes it a little bit flickery, and also the structures here appear, disappear. We can look through the structures, so they are transparent. We can see the stairs down there, and also the boxes will slowly appear. And if we walk up here, it's like a leap of faith, and so on. So if we're, for instance, running away, there's nothing. Oh, I forgot the pole to add. Never mind, we'll add it later on, and if it appears slowly, we'll see that the structure will appear too, and we can interact with it as it was normal geometry. So let's have a look how to build that from scratch. So here we are at a brand new project. It's just an empty URP project, and I only imported the Unity third-person starter assets for URP, and there was nothing else I did. So if we start it now, quickly have a look at it, we'll see that this is basically the same as we saw before. The default materials, everything is here. You can run up here, you can jump, you can interact, and you can walk over here, and so on. So that's basically just the assets themselves. And what we're now going to do is we're going to create a shader graph, which will help us generating this kind of dissolve effect we saw before. So first of all, I created a shader folder here, right click, create shader graph, URP, and I will this time create a lit shader graph. You can also use an unlit shader graph, but the lit shader graph will make it easier to transfer the materials here to the new material later on. So click on it. I'll call it dissolve shader graph. Doesn't really matter. Here we go. And we're going to open it and maximize the window so you can see something here. So first of all, in the graph settings, make sure that it's the lit graph, it's metallic, opaque, font auto. We enable the alpha clipping here, although we won't need it. Receive shadows and everything else. I think we don't need the alpha clipping. Let's see, we'll see it afterwards. And here is our main node. And when creating this experience, which is based on the player position, we first need, of course, you already guessed it, the player position. So create a new variable, vector3, call it player position. This will, we will need that later on, so make sure to remember that name correctly, player position vector3. And that's basically where we start now. So I'm going to create a new node. It's called position, it's the geometry position, and it's the wall position. Just let me do it like this. Here we go. And we want to calculate the distance between our player position, or drag it in, and the world position of the object equipped with this material. So I will now go over here, create a distance node, connect the player position here, move it over here, just minimize the preview. And after getting the distance, we should basically get the size which we want to use for our dissolve effect. So we need another variable, float or vector1 in this case, and I'll call it, just for the beginning, it's the simple dissolve size. Here we go. I'll bring it in. And now we're going to divide the distance by the dissolve size. Divide. So we can tell how far we want to go. And after that, oh, I forgot one thing. Just forget that for the moment. From the distance, we need an absolute node. Absolute. Because we need the absolute value here. And then we'll divide it by the dissolve size. Okay, yeah, that makes sense. And after that, we're going to take that and plug it into the alpha, which is not here because we haven't enabled alpha clipping. Here we go. And alpha. So let's see if this already does something. Switching back. Let's save the asset. We have our two input parameters and switch back to Unity. And I already selected the ground mesh, as you can see here in the scene, just for a better visibility later on. And we're now going to create a material from our ShaderGraph. Select it, right click, create material. I'll just leave it like that for now. And I apply it to the ground mesh. So it's gray already, but that's only the reason because there is no reference to the player position yet. So I'll just shift this into the materials folder, go to the assets folder, right click, create folder scripts. And we need a little script for that. So first of all, let's right click, create C# script, and let's call it, I don't know, dissolve controller. After switching to Visual Studio, just erasing the default stuff, just create two new properties, public game object, and let's call it player, and a public material for the dissolve material, just for controlling. And now we're going to create the update method, and within the update method we're saying dissolve material dot set vector, because it's a vector 3, and it's called underscore player position. I'll tell you in a minute where this comes from, and we'll tell it to set the player dot transform dot position. And that's everything we need for our dissolve controller. And if we're now switching back to Unity, we see that our script is here and that we have to apply it to the object we're going to track. So in this case, I'm going to apply it to the ground object here, and I need two properties to fill: the player armature for the player position and the material. From the materials folder, I'm using the material here, although I could get it with the get material and so on, but maybe I want to control the dissolvement with another object based on the player position without having to query for the right material all the time. So let's see if this will work out. I'll just save the scene, click on play. And what it does basically nothing at the moment. Okay, so that's just the first step. Let's see, dissolve size, let's 0.5 or something like that. Let's see if that will have an influence. Now you can see that on the ground there is already a small circle, which means that the alpha is set to 0 where I stand, but I want the effect to work exactly the other way around. So I'm going back to the shader graph, and before plugging in everything to the alpha, I will grab the output of the divide, create a 1 minus node, and the output of the 1 minus I will set to the alpha. Save the asset. That should basically invert my effect. As you can see here, there was already something going on. If I start now, it's actually working, following our player and making everything transparent. So something that we will need now is the size of the dissolvement. I'll just create a new float, call it dissolve amount. And how can I apply it? Well, I have to take the value from what I'm getting after the divide and multiply it with the amount of the dissolvement. Go multiply. And using this value for actually applying it before the 1 minus. And that should give me a way to adjust the dissolve amount on the material. Let's go to the material. The dissolve amount is 0. I'll just, I don't know, 2. Maybe that's a little bit too much, 0.5. Let's see if we're hitting play. The circle got bigger, just getting out of the maximize to stay in run mode. And the smaller I set the dissolve amount, let's say 0.1, maximize it again, and here we go. This is some kind of dissolving the area around me. That's actually working out pretty nice for, I don't know, 5 minutes of work. So let's see what we have here. Okay. And that looks already pretty good. Now let's see if we can use the UVs of our current geometry for applying a simple noise effect. I'll just create a UV node for this and plug this to a simple noise node. And this simple noise node will then be connected. I'll just put it down here to a step node. And important, this will be the edge input. And on the other hand, we need the multiply output for the input. Just plug it in here in between. Move that a little bit up. It's not too small. Move that a little bit over here. And let's see what changed at the moment. And we see that there is some kind of dissolvement happening when we're going forward. Floor is gray. We'll just fix it by disabling the ground. Here we go. Okay. With a black color, it's a little bit easier to see. Gray is our base color. I could change it by the way later on. I'll show you how to do that. And the ground mesh itself is gray. Yeah. And based on the player position, it will only show the part that far away, I'll just set that to a bigger area, so we won't have to worry about that. Let's set the amount to 0.6. It's also very cool. Okay, so that's working now for the ground plane, and just maximize that you can see it better. It's the 0 starting point here. You can also see it in scene view. That's way better. So you see the dissolvement based on the 0 position now, not the player position later on. And for making this work, we have to expose a few more things. So that's basically like a spherical approach at the moment. So it will definitely check all 3 dimensions, although we can only see the 1 dimension or 2 dimensions x and z in this case. But if we add something like the orange stuff here, I guess we'll just do that by adding a color. Go to the plus, adding a color, just call it, I don't know, base color. And the only thing we have to do here is that we have to drag and drop it here and plug it into the base color, so we can just set everything by hand. And something that would always a good idea for transferring the standard materials here, maybe importing the base map as an image, texture 2D, call it base map. And the texture approach is always the same. Drag it in here, call sample texture 2D. So we will get an RGBA value out of it. Just moved it a little bit up. And the UVs, we can just use the UVs from our object, or we want to use the UVs from our object here. Just put them up here, plug in the UVs, and everything that comes out here will be multiplied with our base color. And that will be plugged into the base color itself. So we are able now to link our base maps here. And what do we need? I would say the normal map would be cool. Yeah, let's do that. Just adding another texture 2D, call it normal map. And you can generate the normal map in ShaderGraph from a texture, either a height map or the normal map itself with a special node. I'll just drag the normal map in here, move that up. We won't need that for the future use case. Let's go here and call it normal from texture. Move it over here and use again the UVs. That and everything that came out here will be plugged into the normal. Very good. Let me move this a little back and up so that it will be a little bit better to handle. This will just be the mapping for our stuff. Okay, save the shader. And let's check it out if we're going to replace something that it's already in the scene. I guess replacing the orange boxes here would be a good start, just to see if they're going to fit in. I select all the orange boxes here. Let's grab the tunnel too. Do we have everything? No, there are just a few more here. And there are still a few here. Okay. Selected objects. Guess the wall prefab is false here. And maybe the tunnel. Okay, let's see. All the boxes. Box, tunnel, and Did I forget something? No, I have everything. So, the wall prefab. Okay, the wall prefab was, I guess, oh, it's the same. Okay, doesn't matter. Just creating the shader here. Should we use the same one? No, I want to use the orange one, so I'll just duplicate it. Let's call it the orange DissolveShader. This would be our ground. DissolveShader. For easier distinction, let's select again the boxes, as we've done before. The tunnel and the wall. And assign the orange DissolveShader. And from the script perspective, the dissolve controller, where we assign the orange material and the player armature. Okay, and let's configure the orange with the orange base color. Let's make it orange a different way. And the base map would be grid. One base map. And the normal map will also be grid. Normal. These maps are part of the Unity package. And we already see that within the radius that's basically here, there is already something appearing or dissolving, or whatever you want to put it. And let's check by playing. We walk over here. Here are the boxes appearing. We go to solid, here's the wall, here is the tunnel, and all the other boxes are appearing as well. There's the pole. And the only thing we have to change now is to add the same trick. It's a little bit dark. The same trick here for the main building and for everything that it's white at the moment. So let's duplicate this one, call it white DissolveShader, make the color white. The base map and the normal map, I guess there is a grid 2 base map. Yeah, okay, it's whiter. It's not a base map. The normal map will stay the same, and we need the ramp mesh, the structure prefab, and all the stairs to be selected. Drop the white dissolvement here, and as you can already see, it dissolves already in the editor. I think we have everything now. And this is all done by just this simple shader here in the little script. So let's go on and test it. Go if we now appear here. The structure does not really appear. Does block us because we forgot to set the script. Sure thing. Sorry about that. Self controller, the right material, and the player armature. Save it, play it. And now it's working perfectly. So everything is going to build up as we're walking here. Faith. Oh, I forgot the pole. I will just select the pole here. Cylinder. Okay, it's a cylinder. This one, the script on it, and the red material, and the player armature. for position. Save it again, play it, and have a look. Nice. So as you can see, the pole does appear and disappear, the boxes, and also the structure. So this is a nice counter dissolve effect, holographic stuff, I don't know. And it's looking pretty cool because of the noise. So that would make sense if you, for instance, use a gradient noise or something else. And if we tweak the values a little bit so that it will not look like, I don't know, cheese, we can definitely use that for something more powerful. So let's do that, and let's see what we can do here to just make it a little bit, how should I put it, more realistic. So for instance, selecting the ground, we can still, when we look in the scene view here, the dissolve size is way too high. So we have to put it down, I don't know, to 0.5 or something like that. And then the dissolve amount we have to put up for about 0.1. Here it is. Maybe the dissolvement size. Yeah, okay, sorry, that was thinking into the wrong direction. We have to put up the dissolve size to, let's say, 0.5. And the dissolve amount 0.001. That's still too little. 2, 3. 1 is actually pretty good. Let's call it 2. Give it a shot. That's just for the ground now, so we have to actually do the same for every other material, but as you can see, it's different now. So you, as you wish, you can make objects appear later or solid later, while others appear earlier, for instance the ground. We'll just leave it in a position where it will work the same, 0.5, 0.02, 0.5, 0.02, so it works basically the same. And as you can see, if we now playtest it, it will be solid in a way earlier stage of approach. You can walk up here or walk into the tunnel, and the tunnel will be solid now, basically solid. You can tweak around the values. One thing I have to say is that this will not work too well with scaling of objects. All the objects are now scaled 1, 1, 1. So if we change the scaling, it will definitely affect the performance or the appearance of the shader. So the effect basically is working. And one thing that's good to know here is, although this is a very simple effect, it has one big advantage and disadvantage at the same time. It's working spherical. So the distance is calculated in all 3 dimensions, x, y, and z. But there may be the possibility that you only want to have it working into, I don't know, 2 dimensions or in another shape, for instance. So let's see, can we see it here? Yeah, you see that this is more solid than the part above. And if we move something further up, just grab the structure prefab here, you'll see that it will fade in a more or less spherical manner. Put it back to the ground. And we're trying to achieve now how to change this shape here. So for instance, you can use the rectangular shape. We'll have a look at that in a few minutes. And if we're going to have a look, if you're going to only use 2 dimensions, we have to split up their positions. So this will get a little bit more complicated now. I'll just leave you the picture of the shader graph here for just rebuilding it or modifying it, whatever you like. So I guess this was enough. If it's not enough time, obviously pause the video and we're going to modify it a little bit. We're going to grab the position, the player position over here, delete these 2 connections. Oh, that was the wrong way to do it. This one and this one. And we're just going to, we can either subtract, I guess splitting it up would be appropriate. Not quite sure if we should just, we're splitting it up. Doesn't matter anymore. Here we go, split into its components, split this here too. And we're just going to, R is X, G is Y, and B is Z. We're just going to grab the R and the Z component here and combine it again. Here is the B component. We have our vector 2 and we can just grab it here. Guess we have to move it further to the left. Like this, the position over here too. And there is the split node. Grab the R, combine, and combine it with the B node, G channel. So here we are. And from that, we should basically, I would say subtract and absolute. Yeah, here we go. Subtract. Use the second one here, and the outcome here will need our absolute value. We already have an absolute node here. We're going to use that here. And we're dividing by dissolve size. That's a float value at the moment. That should work out if we want a uniform approach. And we have as 2 values for the alpha. We have to check for the maximum after we divided it. So move that over here. We have to look which one is bigger now. Maximum. Can we just plug in both of them? I guess that won't work, so we have to split here again into its components, max this one and this one, and the maximum to the multiply node. And then we can use the shader like the way before. You could also use a smooth step here, so we're not bound to use the step function here. It's not that tidied up, but I guess we're just going to try it. So that it should basically work into X and Z direction. Let's see, that already looks okay. Yes, sure. And as we can see here, it's only into the Z and only into the X direction, as this is very uniform. So that would be very useful for everyone who wants to do something like, I don't know, exploring something that is very high, for instance, where you want to see the ceiling or all the walls. I'm just going to try it now. As you can see, this is basically, no, it's not only basically, it's working. It's working. Here we go. You can also see through the walls a little bit. The alpha is working correctly. There is our tunnel. We're exploring the area by foot. The values are also pretty good. Let's jump and jump, and here we go. Yeah, that's cool. Nice. I guess we just have to scale it down. Let's take the ground. Okay. Sorry about that. We already built it in a rectangular way. I mean, it's a quad at the moment. That got me confused. And we should be able to control the extent. So if you don't want to use a quad, we should also be able to control that. Give me a second to thinking. Yes, the dissolve size, because the dissolve size works equally in both ways. And let's just add the vector 3. I mean, we can do it in all 3 dimensions. And rectangular dissolve size. Make it a little bit bigger so you can see it over here. I mean, a vector 2 will also be okay, but yeah, let's leave it a vector 3. And we have to apply this. Where do we have to apply this? Where is the division? Here we go. This is simple. Dissolvement size. Okay, because we're already only going in 2 dimensions. This would make sense if we use a vector 2. Doesn't matter now. We are using the vector 3 here and just... That's not possible, I guess. Oh, it's possible because it only uses the first 2. Yeah, let's split it up into the right values, like R for X and B for Z, combine. Here we go, and then plug this in here. Okay. I'll just move that here, the split here, the combine here. And it's not really visible. And if we want to use all 3 dimensions again, we can just use the positions here. For vector 3, split it up, adding the maximum. I guess we'll do that afterwards too. So we can now, with our X and Z of the rectangular dissolve size, control in which dimensions this effect should spread. Let's have a look. We should already be able to see it in the scene. Okay, everything is 0. Let's call it 1, 1. Okay, that's too big. That's 0. Here we go. Here is the rectangle, and if we now say in the X direction, maybe 5 in the Z, we can control it freely to have maybe like a path or something. We can always try to come up with good ideas. Let me know in the comments, by the way. You see that we can see very far ahead, but not that far to the side. And if we run around, everything will appear. No, it will not, because we haven't set all the other materials. 0.2, 0.5, 0.2, 0.5 for all the other materials. Yeah, nice. And please note that this is working in world direction at the moment. So if I turn around, it's not working into the local direction. And that makes sense because I'm just, let's look at the ShaderGraph before we're talking something like this without having any visual reference. We're not referring to the player position at all and not the player orientation, so you can always go and add the player orientation for the local player forward and apply this effect too. So I'll just leave it like this for a second again for you to copy it, to rebuild it, and then we'll just simplify it to work it in a rectangular way in 3 dimensions. So we have to get rid of all the split and combine stuff because we won't need it, because we want to use all 3 dimensions again. Here we go, there's the subtract, and we can omit this one and just go over here, use this one, place this here, and we just made our whole shader simpler by just using vector 3s. And one thing we have to do now is to find the right maximum value before going to multiply it. And for this we have to add another maximum here. Maximum, and add the third component, and this maximum we will use for multiplication. So every 3 dimensions now should be considered, and we can modify them. Just leave it like this, although this is a little bit confusing. Moved it forward. Simple noise comes here. Arranging the graph is always something very, very difficult. So save asset, I'll just zoom into the, again, here you go, here you have it. Save the asset, go back to our materials, everything should now be here. Okay, okay. The scene will not show anything. The Y is now 1. Let's reset it to 1. Ah, it's only the white shader. Sorry about that again. Let's just set it to 1 on each to have a better view of this. Okay, the position is not centered at the moment, because there is already a player position here. Let's see. Yeah, okay, that makes sense. Let's get over here, and then when we stop it, it will cache the latest player position. Yeah, okay. Sorry about that, I was confused. The amount. Here we go. That's in more rectangular fashion into all 3 dimensions equally. So the 12. So the 12. And let's move in and check it out. Yeah, it's only working into the Y direction. And if we're jumping, we can see that the upper part of this one will only appear if we're jumping high enough. So that would be some kind of, I don't know, lamp or aura, which will grant us insights. For instance, okay, I can move up here, I can go over here, and I see nothing, but I'll just give it a shot. Okay, that hasn't happened before. Over here, okay, I can follow this path by reaching the goal. Yeah, that's, let's say, simple dissolvement shader, which will hopefully help you implementing some cool effects. If you're using that for a game or something like that, let me know, send me a screenshot or something like that. I'll be happy to see that. So thank you all for watching. I'd say that's it for today's tutorial, and looking forward to see you in the next video. Bye.